In this video, we're going to talk briefly about various methods of solving quadratic equations. We'll also be doing additional examples in class. From grade 10, we know that there's really three main ways to solve quadratic equations. We can solve a quadratic equation by factoring. We can solve a quadratic equation using the quadratic formula. And usually we only use the quadratic formula if the equation is not factorable, because factoring is usually easier and requires fewer steps than the quadratic formula does. Or we could use the graphing calculator in order to solve a quadratic equation. Okay, so let's first of all take a look at the quadratic equation. 4x squared minus 9 is equal to 0. Okay. Now, we look at the left-hand side of this equation. We should notice that it's a difference of squares, and it could be written as 2x all squared minus 3 squared is equal to 0. And so we can factor that as 2x minus 3 times 2x plus 3, again, a difference of squares, is equal to 0. And now what we have is a number times another number is equal to 0. Okay, so for example, a times b equals 0. Well, then it has to be true that either a is equal to 0 or b is equal to 0, or both of them could possibly be equal to 0. And so what we want to look at here is two possible cases. Either the first factor here, 2x minus 3, is equal to 0, or the second factor, 2x plus 3, is equal to 0. That's the only way that this statement will be true. And so then we solve each of these equations to get x is equal to 3 over 2, and here x is equal to negative 3 over 2. Okay? And so this quadratic equation has two solutions, and the two solutions are x is equal to positive 3 over 2 and negative 3 over 2. Okay, here's an example where we've checked this equation and it's not factorable. And so if it's not factorable, we want to look at using quadratic formula as an option. Okay, and the quadratic formula is as follows. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure that that division line covers the entire numerator and denominator there. It's not just the square root part over 2a, it's the whole thing over 2a. Okay? So what we want to do is identify the values of a, b, and c in our quadratic equation here. So a is the coefficient of x squared, so in this case negative 2. B is the coefficient of x, so 3. And c is the constant of the equation, so negative 6. And we want to substitute those things into the quadratic formula in order to come up with our solutions to this equation. So we've got x is equal to negative b, so negative 3, plus or minus the square root of 3 squared, minus 4 times a, which is negative 2, times c, which is negative 6, all over 2 times a, which is negative 2, right? And then we simplify. So we've got negative 3 plus or minus 3 squared is 9, and then negative 4 times negative 2 is positive 8, times negative 6 is negative 48, and so we've got 9 minus 48 all over negative 4. Okay, and if we try to simplify this farther, we get negative 3 plus or minus the square root. 9 minus 48 is negative 39, okay, all over negative 4. And what we realize at this point is that we can't actually simplify any further because we can't take the square root of negative 39. Okay? And so using the quadratic formula here, we've discovered that this quadratic equation actually has no solution. Now, wouldn't it be nice if we could actually have a way of figuring that out right at the beginning if a quadratic equation has no solutions? Instead of substituting everything into quadratic formula and taking the time to simplify, is there a way that we can just look at this original equation and determine right away if there's no solution or if there's one solution or two solutions? Okay? Well, actually there is. So we're going to take a look at something called the discriminant, which helps us determine how many solutions a quadratic equation has. Now, the discriminant is something that is very closely related to the quadratic formula because we want to examine the quadratic formula closely to figure out how many solutions the quadratic formula will provide for a particular quadratic equation. And really, it's this part that we want to look at, the square root of b squared minus 4ac. Okay? Because this is the part that will tell us how many solutions that quadratic equation has. Okay? For example, in the previous question that we looked at, we ended up with a negative number under that square root sign, and we know that that told us that, that there was no solution to that quadratic equation. So if that number, b squared minus 4ac, that is under the square root sign, if that number ended up being less than 0, so negative, then we know that there was no solution. Well, what happens if that number under the square root sign is equal to 0? Okay? So if that number is equal to 0, then we have the square root of 0, which is 0. And it means we're going to have negative b plus 0 in the numerator and negative b minus 0 in the numerator. Well, really, those two things are the same. And so we would end up with two answers for x that were identical. Again, negative b plus 0 over 2a and negative b minus 0 over 2a. Okay, so we'd end up with really one solution, okay, or one value of x that will work in that quadratic equation, or sometimes we refer to this as two equal, keyword is equal because they're going to be the same value, two equal real roots. Okay? Now, roots is another word that we use for the solutions for an equation. So for a quadratic equation, we often expect two real roots from that equation, or two different values of x that will work in the equation. Sometimes we get two equal real roots, which is what's happening here. If we get two values of x that are both the same value, that will work as a solution. And then sometimes we get no real roots. So here, this no solution can also be referred to as no real roots. Okay, so it's just another way of looking at it. So either one solution, or it means there's two equal real roots. Okay. Finally, we've covered if b squared minus 4ac is negative, if it's equal to 0, what happens if it's positive? B squared minus 4ac is greater than 0. Okay? So that means we're taking the square root of a positive value, okay, which will give a positive value. So we'll have negative b plus that positive value and negative b minus that positive value. And this is where you get two distinct real roots. Okay? And the reason I've used the word distinct here is to identify that those two values are different. So two different real roots, as opposed to the two equal real roots, or the one solution that we get when b squared minus 4ac is equal to 0. Okay? Now, this b squared minus 4ac is what we call the discriminant. Okay? So what we're doing is we're checking the value of the discriminant to see if it's negative, positive, or equal to 0, and then interpreting what that means. Okay, so for this quadratic equation, we are going to use the discriminant to figure out how many solutions the quadratic equation has. So we won't actually determine what those solutions to the equation are, but we'll determine how many solutions there are. Okay, so again, we know the discriminant is b squared minus 4ac, okay, and we want to look and see if that value is positive, negative, or equal to 0. Okay, so here we know the values of a, b, and c. Okay, a is equal to 2, b is equal to -6, and c is equal to -7. So we'll substitute that into b squared minus 4ac. So again, -6 squared minus 4 times a, which is 2, times c, which is -7. Okay, and we simplify, we get 36. -4 times 2 is -8 times -7, so we get plus 56, which is equal to 92. And because this is a positive value for the discriminant, we know that there are 2 distinct real roots. Okay? So meaning 2 solutions, because we're going to get 2 different values of x that will work for this quadratic equation. Okay, here's another quadratic equation. Again, we want to use the discriminant to determine how many solutions or roots there are in this equation. Okay, so the a value is 3, b is equal to -1, and c is equal to 5. So we'll substitute those values into the discriminant. We get -1 squared minus 4 times 3 times 5. Okay, and so we get 1 minus 4 times 3 is 12, times 5 is 60. And so we get -59. Because this is a negative value, that tells us that there are no real solutions or no real roots. All right, here's a third example. Again, we want to figure out how many solutions this equation has using the discriminant. Now this quadratic equation, we first want to rearrange this so that we have x squared plus 8x plus 16 is equal to 0. Okay? And then we're going to use the discriminant to figure out how many solutions there are. The value of a here is 1, b is equal to 8, and c is equal to 16. Okay, so we substitute that into the expression for the discriminant. So we get 8 squared minus 4 times 1 times 16. And so we get 64 minus 4 times 16 is 64. 64 minus 64 is 0. Now, since the discriminant has a value of 0, that tells us that there are 2 equal real roots, okay? Or in other words, one solution to this equation. There will be 2 values of x that we can get, but both of those values of x will have the same value. Okay? And actually, this quadratic equation is factorable. And so if we were to factor it, we would see that we'd have x plus 4 times x plus 4 is equal to 0. And you can see where those 2 equal real roots are coming from. We're going to get 2 values of x that are both equal to -4.